This is 2.4, Congruent Figures, Parts 1 and 2. A rigid motion is a transformation that preserves length and angle measure. So these are translations, reflections, and rotations. All of the transformations that we have seen so far. Congruent figures are two figures that can be obtained from the other by a sequence of rigid motions. They have the same shape and the same size. Congruent angles are angles with the same measure, and congruent sides are sides with the same measure. So you can see in these two triangles that we have some corresponding parts. So we have two congruent triangles, we know that, and their corresponding sides are congruent. So the short side is congruent to the short side, long side congruent to long side. Similarly, we have corresponding angles are congruent as well. So angle A is congruent to angle D, and we can show that with 3 rainbows on each, or 2 rainbows and 1. And we show that they're congruent with the little equal sign with a squiggle on top. So we're going to identify any congruent figures on this coordinate plane. So we can see that triangle DEF is a translation 1 unit left and 5 units down of MNP. So therefore, triangle DEF is congruent to MNP. Another one is that triangle ABC is a reflection of triangle JKL. And so, since those are rigid motions, ABC is congruent to JKL. And then, the figures are congruent. We are going to describe the rigid motions between the two. So to get from this orange one to the teal one, there's a couple of different routes you can take. One of them is to rotate 90 degrees counterclockwise and then translate it up 4 units. So we will spin and shift. To get between the two triangles, again, we can rotate 90 degrees, and then we'd have to reflect it over the x-axis. You could rotate and then reflect the other way as well. There's usually a couple different options that you could do on how to get from one to the other with a series of rigid motions. You just have to make sure that they're going to end in the same way. So to get from one smiley face to the other, I could start by rotating 90 degrees. Now we know it's sideways. And then the tongue has to be on the other side. So I'm going to reflect it in the x-axis. And then these two smiley faces are the same.